We're going to work on a cumulative review for our midterm, which includes chapters 1 through 3. And here's the first problem. We need to classify 69 as prime or composite. So immediately, let's try to factor it. And you can see the 69 does factor as 3 times 23, which makes it a composite number. So 3 times 23 are prime, and that's our answer for number 1. In the second problem, we're going to evaluate an algebraic expression when we know that x is -2, which means we're going to substitute -2 in where x is. And notice here that we get a negative right next to a negative. And so subtracting a negative number, as you know, is the same thing as adding the opposite or adding a positive. So we're going to get 12 over 8. And that fraction reduces because 12 and 8 are both divisible by 4. So we're going to divide the top and the bottom by 4, which gives us a 3/2 as our answer. So 3/2, answer to number 2. Number 3 is another algebraic expression. This time we have two variables. We know x is 3 and y is -2. So we're going to substitute 4 times 3 minus 3 times -2. As you know from our order of operations, we need to do the multiplication before we do the subtraction. So we're going to multiply the 4 times 3, which gives us 12, and then subtract. So we have, actually I'm going to take that negative with the 3. -3 times -2 is a positive 6. So then I have 12 plus 6, which gives me 18. So number 3, the answer is 18. Number 4 says translate the phrase 5 less than, that's critical there, less than 3 times a number to an algebraic expression. So the 3 times a number, we're going to let x be our number. So 3 times that would be 3x. And the thing about less than is that you always put the number after. The 5 goes after the less than sign or the subtraction sign. So anytime you see less than, just remember that you're going to invert the order. The 5 is going to go behind the 3 times the number. So 3x minus 5 is the correct algebraic expression. So less than, put that in your notes. All right, we've got the fraction 24 over 32. We're going to reduce that to the simplest terms. As you know, 24 and 32 are both in the eighths table. So we're going to divide both by 8, and that'll help us reduce this fraction. And 24 divided by 8 is 3, and 32 divided by 8 is 4, so 3/4 is our lowest terms. In our next fraction problem, we're multiplying fractions. We've got the fraction 7/8, and we're going to multiply times 12 over 3. And remember that when we multiply fractions, we don't need a common denominator. But if you can reduce, it's always good to do that. So this 12 and this 8, as we saw in a previous example, are divisible by 4. So 12 divided by 4 leaves me a 3, and 8 divided by 4 is 2. And oh, well, here we have 2 3s. One on the top and the bottom of this fraction, so those are going to reduce. Those are going to leave us 1s. And now we multiply across. So 7 times 1 is 7, and 8 times 1 is 8. Oh, excuse me, 2 times 1 is 2. So 7/2 for number 6. In our division problem, we want to flip and multiply. So we're going to change that division to a multiplication problem by using the reciprocal of 3/4, which is when you take 3/4 and flip it upside down. That's called the reciprocal. And again, we don't need a common denominator, but we see some things that have common factors. So 4 and 28 and 15 and 3. And 4 and 28 have 4 in common, so we're going to divide 4 into this. And 15 and 3 have a 5 in common. Actually, excuse me, a 3 in common, so we're going to divide that. And multiplying across, we get 5/7. In our next problem, we're adding two fractions. Now we do need that common denominator, so I'm going to set these up here. Common denominator between 9 and 18, we need it to be in the 18's table. So 18 is our common denominator. 9 goes into 18, which makes it nice. And 9 times 2 is 18, so we're going to have to multiply the 5 times 2 to get an equivalent fraction. So now we're just going to add the tops, the numerators, and 10 plus 5 is 15. Keep your denominator of 18, but as always, check to see if you can simplify. And 3 goes into both of these, so we're going to divide by 3. And 15 divided by 3 is 5. And 18 divided by 3 is 6, so our answer is 5/6. So remember, common denominator when you're adding. Also common denominator when you're subtracting fractions, and this is nice because this one already has a common denominator of 8. So we're going to subtract the numerators. That gives us 4 over 8. And as you know, 4 goes into 4 and 8. So we're going to reduce that to 1/2. So our answer is 1/2. So you always want to reduce your fractions if you can. Here we have 5 to the 3rd power. So our base is 5. The exponent tells us multiply 5 times itself 3 times. 5 times 5 is 25 times 5 is 125. You can do that in your calculator with that little caret symbol that I've shown you before. So in the next problem, we have subtraction and multiplication. And as you know from our order of operations, you're going to do the multiplication first. So 4 times 2 is 8. And then subtracting 16 minus 8 gives us 8. In number 12, you've got addition, division, and exponents. So the exponent has to come first. And 6 squared is 6 times 6, or 36. We're going to divide next. Division is going to come before addition. So 36 divided by 3 is 12. And then 3 plus 12 gives us our answer of 15. Okay, we're going to classify each real number as one or more of the following: natural numbers, whole number, integer, rational number, or irrational number. And we've got the definitions below for you to look at. So look at A. It's the opposite of the square root of 9. So negative square root of 9. Now the square root of 9 is 3. So this number is really negative 3. So now let's compare. Now negative 3 is not a natural number because natural numbers only have positive numbers. It's not a whole number because whole numbers only have positive numbers. But it is an integer. It is an integer. Oh, you're going to have to excuse me for having written that that was a whole number. It is not a whole number, but it is an integer, and it's also a rational number because we can write this as the ratio of negative 3 over 1. So integer and rational number. Excuse the mistake there on part A. All right, let's look at 0. 0 is not part of the natural numbers, as you can see from our list below, but it is a whole number, and it is an integer. And again, because we can write 0 over 1, which is a ratio of integers, 0 is considered a rational number. And if a number is rational, then it's not irrational. So that helps us with that. In this problem, we have the absolute value of negative 2. Now, the absolute value of negative 2 is positive 2. We're comparing it to negative 3. And as you know, a positive is always greater than a negative number, so we're going to use the greater than sign. In problem 15, we have negative 6, which we can write as a fraction, negative 6 over 1. We're going to flip and multiply. So we're using the reciprocal of negative 3/4, which is negative 4/3. And then we're going to reduce the 3 and the 6. Multiplying across, we get a positive 8. In B, we have 2 times negative 7, which is negative 14. Remember that a number up against the parentheses means multiply. 16 and 17, we're going to use our properties. So I want you to look below to review our properties. Look at the left side of 16 and look at the right side. And what changed was that in the left side, we multiply the 2x first with the parentheses, but in the right side, we multiply the 4 times 2. That is the associative property when you move parentheses. In 17, you can see that our 2 was distributed throughout the parentheses, so that's our distributive property, which we use quite a lot, so you probably recognize that one. All right, we're going to use the distributive property here to simplify this expression. That negative in front of that parentheses is like having a -1 that you're going to multiply throughout. So it's going to change both signs in the parentheses only. You notice I wrote -3 and -4x. And now we are going to add the like terms. So the 2 and the -3 are like terms, and 2 minus 3 is a -1. And the -4x and the 5x are like terms. -4x plus 5x is 1x. So -1 plus x is our answer. In 19, we're solving for x, and we're going to check the solution. As you remember, we're going to isolate the variable. So let's rewrite this over here so we have a little more room. We want to get that x by itself. So the first thing we're going to move over is that 8, and we're going to add the opposite of positive 8, which is a -8. -7 plus -8 is a -15, and these 8's cancel. So we have 3x on the right. And now we need to get rid of the 3, and we're going to do that by division. So we're going to divide both sides by 3, which makes these cancel on the right. And -15 divided by 3 is -5. So now we want to check that, which means we're going to substitute in our -5 into our original equation to see if we get a true statement. So -7 equals 8 plus 3 times -5. And let's see, we got to do our multiplication first, which is -15. So 8 plus a -15, and 8 plus a -15 is a -7. So these match, which means that our solution checks, which is always a good thing to do in a test, to check your answers. All right, in number 20, we've got x's on both sides of the equation. We need to first put those two x's together on the same side. So we're going to move over our 2x over to the right. This is just a personal choice. And we add the opposite of -2x, which is a positive 2x. That gives us a 3 here. Those two x's are gone. And 4x plus 2x is 6x plus 5. Now we got to move over the 5. So we're going to add the opposite of it, which is a -5. And 3 plus a -5 is a -2 equals 6x. The 5's are gone on the right. Now we have to divide by that 6 so that we can reduce and just get x on the right. And -2 over 6 reduces. These are both even numbers, so I get -1/3. -1/3. Now we have to check that, and that's us checking a fraction, so don't worry about that. Just substitute in to our original problem. We're going to see if we get equal on both sides. And you know that those parentheses mean multiply, so we're going to make this -2 a -2 over 1 so that we can multiply that, and a 4 over 1 so we can multiply there. So you want to do the multiplications first. So 3, there's 2 negatives being multiplied here, which makes this a positive 2/3 when you multiply across, and 3 plus 2/3 is 3 2/3. On the right I have -4/3 plus positive 5. And a -4/3, it's a -1 1/3 plus 5. So see, 1/3, I need another 2/3 to get that 1/3 to be a whole. And then that brings me up to 2. And if I add 3 more, then I get my 5. So these do check. In number 21, again, we're going to solve for x. This time we have the 2 in front of this parenthesis, so you know we're going to use distributive property, and we're going to distribute that 2, which gives us 6x minus 2, and that equals x minus 12. Let's get those variables together on the same side of the equal sign. So we're going to subtract x, and 6x minus x is a 5x. These x's are gone, and I have a negative 12 on the right. Now I need to isolate the x, so that negative 2 is going to move over to the other side by adding the opposite, positive 2. Gives me a 5x on the left because the 2's are gone, and a negative 12 plus 2 is a negative 10. And now we're dividing by 5 both sides to get x by itself on the left, and negative 10 divided by 5 is negative 2. So again, we're going to check, and remember, in your test, good idea always to check your answer before you turn it in, before you turn your test in. So I'm just going to substitute in the x into the original equation. I'm going to simplify the parentheses first, do the multiplication. 3 times negative 2 is negative 6. Negative 6 minus 1 is negative 7. And then 2 times negative 7 is negative 14. And on the right I have negative 2 minus 12, which is also a negative 14. So that checks. For 22, we're going to complete a table. And then we're going to use the table to solve the equation. And this is getting us ready for completing tables for lines. So that's why we're doing this exercise. So we're going to start with x equals negative 2. Substitute that in. Multiplication before addition. So we get 9. Now let's substitute the 0. We like 0 because this goes away. So that's at 1. Now we're going to substitute x equals to 1. So that's 1 minus 4 times 1, which is 1 minus 4 when you do this multiplication. And 1 minus 4, as you know, is negative 3. So we get a negative 3 when we substitute in x equals to 1. And let's hope 2 is it, because that's our last number that's left. So substituting in the 2, doing our multiplication, 1 minus 8 is negative 7. And so x equals 2 is our solution. In the next 2 problems, we're going to translate the sentence into an equation using x, and then we're going to solve. The first one is sum of twice a number and 7 is 13. So twice a number is 2, and it's a multiplication. We're going to use x for the number, so 2x says it's a sum, so that's plus 7, and is always means equals. So 2x plus 7 equals 13, and we're going to solve for x, which means we have to isolate the variable. Let's subtract 7 from both sides. And 2x equals 13 minus 7, which is 6. And now we're going to divide by 2. And so x is 3. The next problem, 3 times a number plus 8 equals the number minus 1. So 3 times a number is 3 times x, plus is a plus, 8 equals is an equal sign. The number, remember, is x, so x minus 1. So it's pretty straightforward. And now let's just solve it. So 3x plus 8 equals x minus 1. We've got to get those x's together on the same side, so we're going to subtract x from both sides. 3x minus 1x is 2x plus 8. The x's are gone on the right, and that gives us negative 1. Let's subtract 8 from both sides so that we can isolate the x on the left. Negative 1 minus 8 is negative 9. And this is 2x. Dividing by 2, we get x equals negative 9 halves. Or you can leave your answer as negative 4.5. It's up to you. The check I'm leaving to you, but again, I recommend you do that during the test. Okay, this one says the sum of 3 consecutive odd integers is 45. So find the integers. So what do they mean by consecutive odd integers? Well, here's an example. 1, 3, 5 are consecutive odd integers. They go in a row. Consecutive means in a row. 5, 7, 9 is another set of 3 consecutive odd integers. What I want you to notice is that between consecutive odd integers, they're 2 apart from each other. Notice that? 1 and 3, 3 and 5, 5 and 7, 7 and 9. They're 2 apart. So when we go to define our variables, which you should always do, and I'm going to give you credit for just defining your variables in your test. Let's let x be the first odd integer. Then the next odd integer is going to be 2 away from that, so we're going to say x plus 2. And the third odd integer is 4 away from x. You see, like the 1 and the 5 and the 5 and the 9, 4 away. So x plus 4 is the third odd integer. So you want to go ahead and define these variables clearly, because that's going to help you get your equation. Now we want to add these because this is the sum. So let's add them and let's combine like terms. And so we get 3x plus 6 when we add those 3. And it says that that has to equal 45. So that's our equation. Again, you're going to get points just for writing an equation, even if you lose track of the answer after that. Okay. 45 minus 6 is 39. 3x equals 39. And so we're going to divide by 3 both sides. X is equal to 13. And what have we found? Well, we found the first odd integer, 13. So the next one is 15. 13 plus 2 is 15. And the third one is 17. So let's check it by adding these up and seeing if we get 45. And you can use your calculator or do it longhand. But yeah, this checks. Those are our odd integers. Again, show me work and declare your variables. That'll really make you get full credit for these problems. All right, now go to the second video for part 2 and the remainder of this review.